The next topic we're going to cover is related to cost behavior. And here I'm going to take an example of a coffee shop so you can envision a business and think of their costs. If we have something like rent, they pay rent and it's the same rent whether there's 1 cup of coffee, no cup of coffee, or 10,000 cups of coffee. So that's a fixed cost. So across the horizontal axis, which is volume of sales, it doesn't change, and the vertical axis is cost. If there is an item like the coffee beans or the coffee cup or the water or stirring sticks, those are variable costs because with every cup of coffee you sell one with a cup, and the beans that cost to make the coffee that go into the cup, those are variable. If you sell nothing, guess what? You have no costs. Not a good scenario because you sold nothing. If you sell a lot, then guess what? It goes up quite a dramatic amount because you've sold a lot, but you're happy to sell a lot because that's why you're in business. So that's a variable cost. And for sake of these discussions, we're assuming everything is aligned, that it's the exact same amount for the first cup or the second cup or the 10th cup, same variable cost, right? So that's what we have as the second category. The third is a mixed cost, where there are some costs that are fixed, regardless of whether you sell 1 or 10,000 cups of coffee, and others that are variable. An example of this might be when you rent a photocopier. There might be a fixed charge just to have a photocopier in your coffee shop. And then with every copy you make, there might be a small charge of a fraction of a cent, let's say, for every additional copy you make. So that's an example of a mixed cost where there's a fixed component, the monthly rent, and a variable component, the fraction of a penny that's charged for each additional copy. The final is a step fixed cost where it stays flat and all of a sudden it jumps as your volume goes up. And it may stay flat again and then jump once again if the volume goes up. An example of this might be the espresso machine. When you're opening up, you don't know how much you're going to sell in coffee, so you have an espresso machine. Then there's a lot of demand. You say, oh, there's a lot of demand. The lines are getting long. People are walking out of our store to go to our competitor. We need another espresso machine and another barista. So that's an example of a step cost that goes up, where when you go from 1 to 2 espresso machines, your costs jump in a flat fashion from one level to the second level. Same with the baristas. We often see this in manufacturing where you manufacture in 1 shift a day, 8 hours. Then as demand rises, instead of building another factory, you have another shift. So you go for 2 shifts a day. Then you sell a lot and you see that there's demand to keep the manufacturing plant going 24 hours a day. And there are companies, particularly in low-cost mass-produced items, where they run 24/7 in manufacturing plants. And those are 3 shifts. So as we go from 1 to 2 to 3 shifts, we'll see those as steps, go from 1 to 2 to 3 levels of cost. So those are our cost behavior. So why do I go through all that? Because we're going to now apply these patterns of cost behavior to a very powerful concept called cost volume profit, or CVP relationships. There's something every company should want to know. What is the break even? Back to our example. How many cups of coffee do I need to sell to start making money? Because below that, I keep coming out of pocket and dig into my savings. Above that, I breathe a sigh of relief because at least the coffee shop is paying for itself. So here we'll need some assumptions that the variable costs for the coffee beans, the water, the cups, etc. are 50 cents a coffee per cup. Next are the fixed costs. The fixed costs are the rent, the manager's salary, etc. Things that don't change, whether you have 0, 1, or 10,000 cups of coffee. And that's, say, $10,000 a month. And price per cup, based on what you think the market will bear in your location, let's say it's $3 per cup. So now the question, how many cups of coffee do you need to sell in order to break even? Here we'll start with the profit equation. And you knew this before you even took this class. You may not have thought you knew it, but you knew it. Here's why. I think it's intuitive to know that profit equals revenue minus cost. Okay, that makes sense. Then you say, well, what is the revenue? Well, if we have a coffee shop, it's the price per cup, P, times the quantity sold, Q. All right, that's the revenue. Well, what are our costs for this coffee shop? Well, we have 2 components of costs. One are the variable costs for every cup of coffee. So that's V. And that we have to multiply times Q because for every cup we sell, we have the variable cost. And then we have to subtract the fixed costs, like the rent or the manager's salary. So now we have the profit equation. Profit equals price times quantity minus variable cost times quantity minus fixed costs. If you go back to your high school algebra, you say, I have a common term, quantity. So we could group like terms. So we have price minus the variable costs times quantity minus the fixed costs. By the way, we call the price minus variable costs the profit contribution. So for every cup of coffee, we make a certain amount of money that is going to be used to cover fixed costs and ultimately generate profit. Next, we want to look at, let's solve the problem. So we say at break even, what does that mean? Well, profit equals 0 at break even. That's what break even means. So we set the function to be 0 equals, the price is $3, the variable cost is 5, so 3 minus 5 times Q, that's the unknown, we're going to solve for Q. And then we'll subtract the fixed cost of 10,000. Doing the math to simplify it to move the Q to one side and the fixed cost to the other side, and then dividing the fixed cost by the contribution, profit contribution, we get the answer, 4,000 cups of coffee per month. And if we're open 5 days a week, 4 weeks a month, that's approximately 200 cups a day we need to break even. And notice that we can do a shorthand of the break even because at break even, the quantity equals the fixed cost divided by the profit contribution, the unit contribution of P minus V. So that's how we solved it for this one case of how much do I have to sell in my coffee shop to break even. But you can imagine for all businesses, we want to know how much do we have to sell in order to start making a profit. So if we sell fewer than 4,000 cups a month, then we're going to lose money because we won't make enough profit contribution to cover our fixed costs. If we sell more than 4,000 cups, then we're great because we'll have more profit contribution than fixed costs, and that difference becomes our profit. So that's why break-even's an important number is maybe an emotional or psychological number that once you crack past that number, then you're making money, right? So that becomes a minimum goal just to cover your own costs. So this is more generalized tool than you might imagine. The profit formula that we see in green here, profit equals the unit contribution times quantity minus fixed costs, that can be used for a whole bunch of things. For example, how many cups do we need to earn 10,000 a month? I don't want to earn 0. I want to earn 10,000. Well, how many cups do we have to sell to earn 10,000? Or if I raise the price to $4 a cup, what happens to my break-even point? I will have to sell fewer cups of coffee. We know that, but how many fewer? And third, if I can reduce my fixed cost to 8,000 by saving cost on rent or negotiating harder or maybe hiring a less expensive manager, what happens to my break-even point? And the fourth example is if I spend more money on advertising to generate traffic, how much do I have to increase sales by in order to make that a profitable investment? So you can see something as simple looking as the profit equation can be used for many different scenarios in order to simulate what would happen if we raise price, lower price, invested more in fixed costs, etc. These would be different illustrations of CVP, right? So a very simple thing, simple tool that we use for initial calculations for a business opportunity.